Look up at the night sky on a clear evening, even far from city lights. Most of what you see is darkness. Stars are scattered across the sky, but between them lies an immense blackness. At first glance, this seems unremarkable. Darkness feels natural at night. Yet for centuries, scientists recognized that this quiet darkness hides a profound puzzle. If the universe were infinite, eternal, and filled uniformly with stars, the night sky should not be dark at all. In such a universe, every line of sight should eventually end on the surface of a star. The sky should glow with the combined light of countless suns, bright in every direction. Night should be as luminous as day, and yet it is not. This contradiction became known as Olbers Paradox, named after the German astronomer Heinrich Wilhelm Olbers, who discussed the problem in the early 19th century. But Olbers was not the first to notice it. The puzzle had been recognized much earlier by thinkers including Johannes Kepler and Edmund Halley. Olbers' contribution was to clearly state the problem and challenge astronomers to explain it. Early explanations focused on the idea that dust or gas might absorb starlight before it reached Earth. At first, this seemed reasonable. If enough material filled space, it could block distant stars from view, but this solution quickly collapsed under scrutiny. Any material that absorbed light would heat up over time and eventually glow itself. Darkness could not be maintained by absorption alone. The paradox lingered because it quietly challenged a deeply held assumption that the universe was static and eternal. For much of history, scientists believed the cosmos had always existed in roughly the same form. Time stretched infinitely into the past, and stars had been shining forever. The true resolution to Olbers' paradox emerged only in the 20th century with a new understanding of the universe itself. The key insight was that the universe is not eternal and not static. Modern cosmology shows that the universe has a finite age, about 13.8 billion years. Light travels at a finite speed, which means we can only see objects whose light has had time to reach us. There are vast regions of the universe beyond this observable horizon. Their light simply has not arrived yet. The sky is dark in part because we are not seeing all that exists. Expansion plays an equally important role. The universe is not merely growing larger. Space itself is stretching. As light travels across expanding space, its wavelength is stretched as well, shifting it toward the red end of the spectrum. Light that was once visible may arrive at Earth as infrared or microwave radiation, invisible to the human eye. The universe is not dark, it is glowing in wavelengths we cannot see. In fact, the faint afterglow of the Big Bang still fills all of space. This radiation, known as the cosmic microwave background, is the cooled remnant of an early hot universe. It is uniform, pervasive, and invisible without special instruments. Olbers' paradox, once a philosophical puzzle, helped point toward this deeper cosmic truth. What appears to be empty darkness is not emptiness at all. It is evidence of a universe with a beginning, a history, and a structure shaped by time and expansion. The darkness of the night sky is not a failure of starlight. It is a quiet confirmation that the universe is dynamic, evolving, and far more subtle than early astronomers imagined. This was an audio article from the History of Science series, exploring how simple questions have led to some of our deepest discoveries about the universe. Thank you for watching.